Imagine an object so powerful that nothing can escape from it, not even light, the fastest thing in the universe. An object with gravity so intense that it bends space and time itself, distorting the paths of stars and even changing how time flows. This remarkable object is called a black hole, and it is one of the most mysterious and fascinating phenomena in modern astronomy. Although the name, black hole, suggests a giant hole in space, that description is somewhat misleading. A black hole is not an empty hole or a tunnel leading somewhere else. Instead, it is an incredibly dense object created when a huge amount of matter is compressed into an extremely small region. Because so much mass is packed into such a tiny volume, the gravitational pull becomes extraordinarily strong. To understand why this happens, it helps to think about gravity itself. Gravity is the force that attracts objects toward one another. Earth's gravity keeps us firmly on the ground, the moon's gravity causes ocean tides, and the sun's gravity holds all the planets in orbit. Every object with mass has gravity, but the more mass an object has, and the more tightly that mass is packed together, the stronger its gravitational pull becomes. A black hole represents the most extreme example of gravity known in nature. Imagine compressing the entire mass of our Sun, which is about 333,000 times heavier than Earth, into a sphere only about 20 kilometers, 12 miles, across. The resulting object would have gravity so powerful that the speed needed to escape from its surface would exceed the speed of light. Since nothing can travel faster than light, nothing that crosses a certain boundary can ever escape. This boundary is called the event horizon. It is often described as the point of no return. If a spacecraft remained safely outside the event horizon, it could still fire its engines and fly away. However, once it crossed the event horizon, escape would become impossible. Every possible path through space and time would lead deeper into the black hole. Because light cannot escape from inside the event horizon, black holes are invisible. Astronomers cannot point a telescope at one and see it directly like they can with a star or planet. Instead, scientists detect black holes by observing their effects on nearby objects. If a visible star orbits an invisible companion with an enormous mass, that unseen object may be a black hole. Likewise, gas falling toward a black hole becomes extremely hot, emitting intense X-rays before disappearing beyond the event horizon. These clues allow astronomers to identify black holes even though they remain hidden from direct view. Black holes are often surrounded by a glowing ring of hot gas called an accretion disk. As gas, dust, and even entire stars are pulled inward, they begin orbiting the black hole at tremendous speeds. Friction between the particles heats the material to millions of degrees, causing it to shine brightly across many wavelengths of light. Ironically, while the black hole itself is completely dark, the matter surrounding it can become one of the brightest objects in the universe. A common misconception is that black holes act like giant cosmic vacuum cleaners, sucking in everything around them. This is not true. If our Sun were magically replaced by a black hole of the same mass, Earth would continue orbiting exactly as it does today. The only major difference would be that our planet would become cold and dark because the Sun's light and heat would disappear. A black hole's gravity follows the same laws as any other object with the same mass. It only becomes overwhelmingly dangerous when something ventures very close to it. Scientists believe black holes exist throughout the universe. Some are only a few times more massive than the Sun, while others contain billions of solar masses and sit at the centers of galaxies. Our own Milky Way galaxy contains a supermassive black hole called Sagittarius A*, located about 26,000 light-years from Earth. Although it is unimaginably powerful, it poses no threat because of its enormous distance from us. Black holes challenge our understanding of physics. They test the limits of Einstein's theory of general relativity and raise profound questions about space, time, matter, and information. For decades, scientists have studied these mysterious objects to better understand how the universe works. Each new discovery reveals that black holes are not merely cosmic curiosities. They are fundamental to the story of stars, galaxies, and the evolution of the cosmos. Next chapter. The life and death of stars, how black holes begin.